Good morning, everyone. Ronald here, and welcome to another live stream on this beautiful Thursday. Well, assuming it's Thursday for you too. I know we have everyone from all around the world. So, good morning to Sanjita and Abuela Dambada. Yeah, everyone's here and everyone's getting ready to get started. Um, Linjet, Mamuji. Some of the names are a little difficult to pronounce, so forgive me if I screw it up. But today we are going to be talking about machine learning, experimentation in Visual Studio Code. And our guest is going to be Alex Kim. So I want to go ahead and introduce him and get started because we got a lot of stuff that we want to cover. So feel free, everyone in the chat. Anytime you have any questions, feel free to jump right in and throw in your questions, and I'll make sure to get to everybody. Okay, Alex, how you doing?
Hello everyone. Thanks for having me here.
Yeah, welcome. Everybody is applauding on their end, and that's it. So, Alex, can you tell me a little bit about today? What we're going to be talking about?
Right, so today we'll talk about how you would go about working on machine learning projects in VS Code. So basically, how do you do everything that a typical data scientist or machine learning engineer or anyone who learns machine learning can train their model, do their experimentation, everything without leaving their favorite IDE.
Nice. Now, have you always worked with machine learning when you first got into technology also, or is this something you kind of segued into? Because I've always been interested in that on my end also, but I remember the first time I ever got into computers, just thinking about AI itself sounds super intimidating versus just like building an app that looks like a website. How'd you get into it? And was it always what you did?
Well, my background is in physics. So after deciding that I didn't want to continue in the academia, I transitioned into industry and worked as a software engineer for a few years. And after a couple of years doing that, I realized that I was missing kind of the math and statistics parts of the academic work that I did before. And machine learning and data science seemed kind of a perfect mix of doing some software engineering work as well as doing some math. And the processes, as we'll see later, and as I'll describe in the live stream later on, that they're very similar, like in physics, at least in the part of physics that I did, kind of applied experimentation. The workflows are very similar. So yeah, that's kind of after a couple of years doing software engineering, I kind of took a couple of courses, read a few books on data science and machine learning, and yeah, been doing that for the last 6-7 years.
Nice, very cool. Well, let's not go ahead and delay anymore. Let's go ahead and see what you'd like to show us. And I'm gonna put my special AI background music as we start watching and asking some questions.
All right, so uh, before we go into kind of the focus, obviously the focus of today's live stream is the DVC extension for VS Code. But in order to work with the extension, we gotta set the stage and introduce some context for what we're about to do.
Okay.
And I kind of typically think that the best way to do that is actually introduce some kind of more or less real problem, or as close as real as we can get. So I have this kind of toy machine learning problem that we'll solve today, like very quickly without going into like minute details.
Okay.
And this problem is about like predicting customer churn that many businesses are familiar with, right? So they have some existing customers, and different customers have different likelihoods of actually leaving them towards their competitor. And if you can predict that, you can potentially save businesses a lot of money, because oftentimes it's much cheaper to retain an existing customer compared to attracting new ones. And we'll do that on this toy data set that comes from Kaggle. And I have a few rows from this data set here. And this comes from like some fictional bank. Every line in this data set describes some features of a customer, like their where they come from, like the country, their credit score, how many products they have with this bank, their estimated income. And finally,
Okay.
this last column here is whether they're likely to leave that bank as a customer or not, like whether they left in the past. And the goal for us is to see if we can train a well-performing model that will be able to predict for future customers if they're likely to leave the bank or not. So
Nice.
this is kind
So
of
quick question though. So for the DVC extension, which I saw that which was in our title. So two quick questions. What exactly does DVC stand for people that are completely brand new? And are we using the extension at this second with this example that we're using, or you're about to mention it?
Yeah, so I'm about to go into that, but that's a very good question. Like, what is DVC and what is it for? And then once I introduce DVC, we'll jump straight into kind of the extension.
Okay.
So DVC is widely known in the data science community. Originally, when it was first introduced in, I think, 2018. So DVC stands for Data Version Control. And the reason that DVC is kind of widely used in data science is because typical data science workflow is significantly different in like key areas from a typical software engineering workflow. With software engineering, the focus is obviously the code itself and maybe some configurations when it comes to like deployment and the environment configurations. With data science workflow, there are additional things that are equally important. So data is being kind of the first-class citizen when it comes to data science workflows. And data constantly changes, right? In any business, you have more data coming in and you frequently retrain the model. So you need to be able to keep track of what the data sets that you're working with. On top of that, we have different algorithms, their configurations and hyperparameters. So basically, all of that is important, like the code itself, the algorithm that we're using, the data versions, and everything. So with DVC, it allows you to version all of that. Like, well, Git, you use Git to version your code, obviously, but DVC integrates very tightly with Git that it allows you to version your data sets as well. And that allows you complete reproducibility for your machine learning experiments. So if you run some experiments, train some models today, like you can return to the exact same experiments weeks or months from now and get the exact same results. That's important.
All right. So Michael, you just got your answer regarding to like what DVC is, and CFF. We're going to be getting into that, into like how to use it. Yeah. So go ahead, continue.
You
Alex.
can think of DVC as Git for data, because DVC is an open source, just like Git, and it's also a command line tool, just like Git. But it's also a lot more than just a data versioning tool. Like it has experiment tracking functionalities, which again, as I mentioned, data science workflow is highly iterative. So it requires you like a lot of trial and error in order to get to the best performing model. You also need visualization capabilities so that you can create some plots and actually get insight into how your model is performing. And with the DVC extension, as we'll see in a few minutes, you also have like those capabilities to visualize what's happening. And if any of you in the audience right now, if you work with deep learning models, like we'll know that it takes like quite a bit of time to train a deep learning model, like hours, sometimes days. So you want to be able to peek into what's happening with the training process while the model is training. So the extension also provides you the ability to live monitor the performance of your model.
Nice.
So,
cool.
Without going into the details, I'm training my model in this Jupyter notebook. Like this is the tool that pretty much every data scientist or machine learning engineer knows very well. Here I have some Python code that loads my data set. does some basic exploration, data kind of exploration, splits my data into train and test sets, using the train data set to train my model and the test data set to actually evaluate its performance. For example, like display a confusion matrix here. Basically, a perfect model will have like ones on the diagonal and zeros on the up diagonal values. And we also compute some very common classification metrics, such as F1 score and area under receiver operating curve. Because what we essentially have is a binary classification model. We want a model that will be able to predict whether the customer is going to churn or not. So this is what we do in the notebook. And now let's get into the extension. So first of all, you can find the extension here in the marketplace by simply searching for DVC. Mm-hmm. And you can think of this extension as, what would be the right analogy? So for those of you who use like GitLens for Git, right?
Okay.
Or maybe use like another graphical user like GUI application such as SourceTree for Git. So think of DVC extension as basically this GUI on top of Git that allows you to generate your experiments. So the first thing that I want to show is that you can have a table of all the experiments that you have. So for now, I don't have any experiments other than what I have on this branch that I'm showing. So
quick questions. How is this different from Kubeflow? Black Current 07 just asks.
Kubeflow, I'm not very familiar with Kubeflow, but from
I've never heard of it.
From what I remember, it's more of an kind of orchestration tool for like running data science workloads. So kind of remote distributed workloads. What I'm going to show here today is everything's going to be running on my local machine right now. And Kubeflow, again, from what I remember, it's not like really an ML experiment platform. It's more for like running and training your models rather than tracking the performance of the models.
Got it. And for the code that you're going to be demonstrating today, will any of it be available if anyone wants to experiment with it, or not really?
Yes, it's available. Actually, I can share a link to it right away.
Daryl Farrell just asked that.
Yeah.
And then we'll jump right in.
Maybe I shared the link with you, so maybe you can share it with the rest of the audience. This is the repository that I'm using right now.
Perfect. Our producer will do that. But yeah, go
ahead. Right. So here's we have like some parameters for my experiments, like what features we want to use in order to train our model, how do we want to split our data set between train and test, and I just selected like a couple of hyperparameters that I want to tune for my model. And DVC extension automatically recognizes all the kind of moving pieces that I have in my project, and it allows me to run more experiments. For example, this max depth parameter, this is the maximum depth of decision trees used by my model. By default, I had it set to 5, but let's say I have a hunch that maybe, just maybe, 20 will give me like better performance. And by better performance, let's imagine that this F1 score is the key metric that I care about. So I just created an experiment. DVC extension automatically ran this experiment for me. And I got a new entry in this table, right? So let's look at what we've got in this table. First of all, we've got our metrics, so F1 score and area under receiver operating curve. We've got our parameters that I tuned. So I changed maximum depth from 5 to 20. So this is reflected here. It shows me the data sets that I'm using over here, and all the other things that have been extracted from my parameters and like my project in general. And I can generate like a few more experiments. Let's say this time I want to play around with the number of estimators. So I can select this hyperparameter. By default, it was set to 50. let's imagine I want to double it.
Mhm.
Then DVC extension is going to run this for me, and I've got another entry here. And actually, it turns out that this experiment is even worse when it comes to the model performance. So I got like 2%. So this is F1 score of 50% compared to like 52 that I had with a previous experiment. So not only that, but DVC extension also gives us the ability to visualize our experiments. For example, over here, so when I click on the plots section in the extension, I can see my receiver operating curve. I can choose exactly what commits what experiments I want to compare with each other. So a perfect model, for those of you in the audience who are already familiar with like binary classification metrics, like a perfect receiver operating curve would immediately go kind of to the top left corner. So basically, the higher this curve is, the better. But it looks like all three experiments that I have like on the head of my branch and the two more experiments that I generated, they're kind of very close to each other. And we've seen that like another evidence of this was the F1 score values were also kind of close to one another. We can also compare confusion matrices, right, that I showed you in the notebook, but now we can see them in the extension. And here, like I generated two experiments like manually, and that's totally fine if you know like exactly what parameters you want to explore. But typically, we want to explore many combinations of parameters, right? And for this reason, I prepared this short Python script. And what it does, it basically tries many different values for the number of estimators and the maximum depth of decision trees. Like number of estimators will have values of like 50, 100, 150, and 200, and maximum depth will go 10, 15, and 20. So this essentially creates like a two-dimensional grid of values, right, that I can explore in my model.
Okay.
And with this for loop, I'm basically queuing up many different DVC experiments. So let's see how it works. I'm going to run the script and go to my experiments table. And we can see that this script adds more and more experiments to the queue. It doesn't run them immediately. It just places them in the queue, and we can see that all these parameters are like all different pairs and combinations of the hyperparameters that I wanted to tune.
Got it.
Now I've got a few of them here, all of them queued up. We don't have the metrics yet, right? Because we need to actually run them. And doing this is as simple as just clicking this button over here, start the experiment queue, and the extension automatically triggers all of them. So it's going to take like a minute or so. Let's take a short break here for any additional questions we've had so far.
Perfect. So now let me ask you this. For some people to really appreciate this, maybe I should ask, like, in the absence of this, like, what's the extra work that you would have to do? What are the steps in order to be able to like get the same results, so that we could see how much time this is actually saving us?
Right. That's a very good question. So assuming that you've experimented with your notebook already, so you have some prototype of the model, it may not be the best performing model. Like it's as simple as essentially creating what I have here is a DVC pipeline. I have only like one stage here that runs my notebook, but you could potentially have multiple stages here that could depend on one another. Like you could have a typical pipeline would look something like this. You'll have a stage for data loading and pre-processing. You'll have a stage for splitting your data between train and test subsets. There would be a stage for training the model and the final stage for evaluation. So you could have like 4 or 5 stages like this.
Okay.
And once you have the pipeline defined in this DVC YAML, that's it. Like the extension automatically recognizes the structure of your project. It will be able to parse the relevant information. So So
So
kind
what
of
would you
setting up
say?
the DVC pipeline is the only requirement here.
So like in your world with the extension, you end up like probably saving like during the course of the day, probably like a couple of hours of extra work.
There's
Right?
several benefits that I see here. Saving time, but also, I guess, very much relevant to this is context switching, right? Uh, all the engineers in the audience, they know that context switching is expensive. If you do something in your IDE, but then you have to switch to like a different browser window, a different resource to check the results, like
Okay.
that is expensive. Right? So we want to do, and this VS Code extension allows you to tune your parameters, change your code, and look at the results all in one place.
When you
Like,
say expensive, are you talking about in terms of performance?
like mental context switching, of course, like that's one thing. The other thing is, if anyone in the audience like tried other experiment tracking tools that are out there for like exist for machine learning practitioners, typically it requires you to do two things at least. It's embed their like framework specific code into your application, so that introduces you to a little bit of a lock-in. And the second thing is when you experiment and all of those training metrics and everything, you have to send that typically to some external database or a service, right?
Mm-hmm.
And many businesses, they don't want to do that. Like they want to keep their data locally, like in their within their own infrastructure. With this VS Code extension, everything happens locally on your machine. The data is not being sent anywhere else. So you can compare your experiments right in your IDE. You don't have to like open a separate experiment tracking platform window and look at the results over there.
So here's another question. This one is from Dara Farrell. They ask, could you discuss how this will change if this was done in a dev container?
It wouldn't change. It would be the same, like exactly the same. I even ran the same thing for if you've tried on GitHub, you've got like code spaces, so you can launch like a virtual machine directly in the browser, open up VS Code. It works exactly the same.
Got it. Nice. Now, while your script is still running right now, right?
No, it's already complete. But
Okay.
if we have more questions, maybe I can address one more and then continue.
Let's see. It is interesting to talk. No need for. All right. Yeah. No, we can continue right now. I've
Okay.
hit these questions. Yeah.
Right. So what happened was now the extension executed all of the experiments that I put in the queue, and we can see some of them got better results than others. It's not immediately clear like which one's the best. So in the table, we have an ability to sort columns by the value by ascending or descending order. So now we see that we've got this experiment that seems to have the best performance. So we've got like 54.5% F1 score compared to like 52% what we had before. Like this is more or less a significant improvement. So let's say I want to continue with this experiment. At this point, I've got like a couple of options. If I right click on this experiment, I can either create a new Git branch out of it, and I can sort of continue building on top of this experiment, hoping to improve it even more, and then maybe like create a pull request into this branch that I work on right now. Or I can just apply this experiment directly to my workspace. So if I do that, what happens is just my local workspace gets reset to the same state that it had when it ran this experiment. What I mean by that is all the code and all the parameters get reset to those values, as well as my metrics.
Mm-hmm.
Basically everything, like all the visualizations. And now at this point, if I'm satisfied with my experiment, I commit it. I can say like I tuned hyper parameters. And there you go. So now that experiment is registered, documented in my Git. Like all my teammates, they can just grab this branch, pull the latest changes, and they will have the exact same results. Like if they run the same experiment, they'll get the exact same results.
Nice. I love
So
that. I think people would appreciate that.
yeah, and now imagine like a couple days later, like you come back to this and you have some more ideas of what you can improve. Like again, this goes back to my initial comment that data science workflow is highly iterative, right? So you think that maybe a different model type, like we use the random forest algorithm, but maybe you think that light GBM algorithm may give you better results. So you try that out, and you see that you do get some improvements here. So you keep the same thing. So you apply this experiment that you deem to be successful, and then to your local workspace, and say, this time we tried light GBM model, and then we commit it to our Git history. So everyone who so I shared the link to the Git repository. You should be able to see both commits that I just made in there. So a few things, additional things that I'd like to mention with the extension is DVC, as I mentioned, originally stands for data version control. So this data set that I've been using to train my model, imagine if you had like a different version of the data set. Maybe a few weeks passed, you got more clients, so let's try and simulate this by just copying a few rows in here. Right.
Let me ask the producer to drop the link in. Producer, can you throw the link up? Alex, put the link in the chat.
Okay. Let me. So I don't think I can add anything in the chat, but in the our streaming platform, I shared the link. So if someone can drop the link.
Yeah, she's showing it now.
Okay, that'd be good. Thank you. So now what I'm simulating is the idea that a couple of weeks passed, we got more data, right, about customers who left or stayed with the business. So what I did is I duplicated these lines to simulate this. So now I've got a different data set, and I want to train my model. So it's as simple as like the data set has changed, right? Now I can rerun my experiment by simply clicking this button. And we'll see what happened to our metrics. So actually, it looks like our metrics decreased because I'm not sure why. Like it's hard to identify exactly the reason, but with this new data set, imagine if we still want to commit our results despite the metrics being slightly lower. One thing that we'll notice here is that in addition to like different metrics in here, the new file that was changed is this like meta file that tracks our data set. So first of all, the hash of our data set has changed. So this is how DVC knows that the data is different. The size is different. It's just slightly larger because I added like about, I don't know, 15 or 20 new rows.
Okay.
So we can create a commit out of this and say like updated data set and create another commit out of it. And imagine if someone else, like not me on this machine, but someone else did that. The only thing that I would need to do is to basically click DVC pool. So when you install the extension, it adds a separate section in the source control tab. Like there's a first section that everyone's familiar with to work with Git, but then it adds a second section to work with DVC. So it allows you to essentially pull and push your data as opposed to your code that you would do with Git. And
now let me read a comment that Jennifer Del Figueredo put. I think she was referencing. She said at Black Current 07, DVC is for large data sets and models that do not fit in Git. Alex, what do you feel about that statement? Is that like an accurate
Yeah,
representation?
that's exactly the goal. Is, I mean, in this toy problem, I'm using a fairly small CSV file, so like most people would probably consider that it's fine to just put it in your Git repository. But imagine, and this is typically the case with like many machine learning projects like these days, that you deal with gigabytes or tens and hundreds of gigabytes of data. There's no way you can version it in Git directly, right? That's would be unreasonable. So DVC allows you to keep track of your data in Git without actually hosting your data sets in Git. The data sets will live in some remote location, like in this case, if we look at the configuration here, all the different versions of my data live in AWS S3 bucket. And DVC supports pretty much anything you can think of. It supports all major cloud providers, SFTP, FTP, SSH, network attached storage, and so on. So you can configure that DVC remote. It's sort of like analogous to your Git server, like Git remote, where you want to store your Git history. But DVC stores different versions of data sets instead.
Nice. It's a great, concise way to think about it then.
Yeah. And yeah, I'd like to, I guess, one last thing. So I've changed my data set here, right? So I've added like a few more rows. And now imagine that that data is, I don't know, got corrupted, or by mistake someone added that, or whatever. So you want to switch to like a previous version of the data set that you had like on a previous commit. So it's as simple as like you can find a particular commit hash and just check out that version of the data there. Or we can type, let me actually clean up. And
now the data set you said you switched, it's the churn underscore modeling. It's a different file, or you
yeah,
just
remember I added like a few lines in here. So these are
okay.
the new lines, and I retrained the model. And I encourage you to think of a hypothetical scenario where you decide that the new data that you added is actually not good data, or for whatever reasons. Maybe like it wasn't cleaned properly or what have you. So you could switch to a previous version of the data set by simply running like git checkout. And here you would paste the specific like commit ID. I know that in the previous commit, I had the version that I liked, so I can just switch to the previous commit and just point to a different, basically what I'm doing is I'm checking out this reference to the data from the previous commit.
Okay.
Okay, not, oh, I forgot the @ sign here. There we go. So we switched our reference file, and now with the simple click of a button, simply doing DVC pull, what's going to happen is my data set gets reset to the previous state that it was on, like on my previous commit. So what I can do is simply just provide a message saying like reset data set to like earlier version or something. And yeah,
rerun reverting back to the previous state.
Yep, exactly. So it's a matter of simply like finding the right Git commits or Git branches where you had the data set that you liked. So that's pretty much it. I guess my concluding notes would be that with DVC extension, it turns your VS Code IDE into like a full-featured ML experimentation platform, so that you can change your parameters, change your code, and experiment on your machine learning models without leaving your IDE. Again, it comes down to like context switching, using separate, you don't need to use like a separate external database to send your metrics. Like everything's happening locally.
Nice. That sounds great. And thank you for this presentation. Yeah, because AI is new to me, and I know like some users here, it might be the first time that they're learning about AI or hearing about it, like and actually watching it, because I'm pretty sure everyone's like heard of it. But if someone wanted to like start getting into artificial intelligence and doing like work similar related to this, any type of advice you'd give them from your experience?
I would say definitely check out. So if you want to learn specifically like more about how DVC fits into machine learning workflows, so at Iterative, which is the maintainer of DVC, we have a learning course. So let me find the link to it.
Cool. And Curious
It's,
Drive, yes,
it's
that is
free.
me.
Sorry?
Sorry, no, I was just responding to somebody. Someone was saying they've seen me before on doing LinkedIn courses. I'm like, yes, that is me. You're not wrong. But as you were saying, Alex, you were mentioning some courses related to that.
Yep. At learn.iterative.ai, I dropped the link in the comment section. So maybe you can share it with the audience.
Perfect. Producer, if you could share that, that would be great.
It contains some, like, again, because DVC is so tightly integrated with Git, and this is actually was the original goal, that course itself goes into some introductory kind of Git mechanics for those of you who are maybe need a refresh on that. And then, yeah, it talks about like DVC for data versioning, machine learning pipelines, and so on.
Nice. Well, this has been awesome. Thanks so much, Alex, for joining us. Loved
Thanks for having
watching
me.
this and learning about it. And that will be concluding our session. Alex, for people that might want to like reach out to you, how could they get a hold of you?
Right. So I'm not very active on social media. I have like GitHub and LinkedIn on Twitter that you can find me at like Alex 000Kim. That was in yeah, that's in
Yeah, right there on your
my name tag in the corner. Yeah.
Awesome. And on our behalf, everybody, if you guys want to follow us on TikTok and YouTube, producer, if you could show our links, that would be awesome. We're quite active over there also, and we try to be like hilarious on TikTok. But until then, we will see you guys on our next stream. Okay. Thanks a lot for joining. See you guys later.
Thanks, everyone. Bye.